Alright, welcome to Chapter 3, Section 2, called Slope. This is for Math 8. Alright, so looking at the front screen, just like all my other videos, the first thing we should notice is a due date, and that's on the student screen. You don't see one on my screen. They just don't give me one in the teacher preview, but yours should always show you when this was due. Attempts, so this is showing me I'm on attempt number 1 of unlimited attempts. Means I can submit this assignment as many times as I would like. I just can keep coming in and trying over and over and over again. Number of questions, there are 5 questions on this particular assignment. So there will be anywhere from 1 to 10 questions, just depends on the section and what was available. Grading policy, best score, meaning whichever attempt is the best one is the one you keep. Partial credit is enabled, which means that, if you answer 1 of 5 questions, you get to keep the points for your one question. This little reminder just says, please remember, once you start the homework, you must finish it before you can work on anything else. So that means if I click start here, and actually even that previous screen is kind of we've already started it, or at least the system considers it that way. Now we're here on the bottom right corner of your screen. You don't see it on mine, but you will see it on yours, is the submit assignment button. Always, always, always click the submit assignment button. Number 1, lets your teacher know you've been working on it and what score you have. And number 2, it will stop the system from locking you out of other assignments. If you just leave the screen, the system assumes that you still want that attempt to stay open, because not all programs allow you to have unlimited attempts, and like we do. So those attempts do matter in some other programs. So for us, it's, you have unlimited, you can click submit, come back in when you need to. It's going to remember where you are, so whichever question you left off on is the one you're going to start back up on. You're not going to start back at 1. Unless, of course, you left off on 1. Alright, so looking at the side here, we have explanation. This is going to give us the solution to the question we are looking at right now. So it's going to tell us we're losing our question attempt because it's going to give us the answer. So it's not going to give you the answer and then have you come type in the answer. It's definitely going to make you, take a look at the answer and then try this again on another attempt. Example literally shows you an example of this problem type. So something very similar, and instead of the sweet company transporting sugar to market, it's a bucket is being filled with water. Same idea, we have an item, and in this one it's cost that's going up, and this one it's, the amount of water in the bucket that's going up, right? So then they ask you 2 questions, something along these lines, just to answer some questions about the graph, and if we understand how to read this. So we'll go through and complete this type of question here. You can click example again to get another example. And then you can also message your teacher straight from the screen. It will attach the question to your message, which makes it really convenient for us to answer or figure out where you need help. All right, so let's go ahead and read this. It says, this sugar sweet company needs to transport sugar to market. The graph below shows the transporting cost in dollars versus the weight of sugar being transported in tons. Use the graph to answer the questions. So one thing, this whole section is called slope. So that's a really, really big clue. We're going to be dealing with slope. And if we don't remember slope from our previous lessons, slope is rise over run, which we can also call the change in y over the change, whoops, I don't know why I was putting an I there, change in x. And you can, sometimes you might see this delta symbol. Instead of that, you'll just see delta y, delta x. It means change in. It's the same idea. Just depends on where you're looking when you look that up. But that's all the triangle means, is it's called delta, and it means change in. And what this means is we're subtracting from 2 points, we would subtract the y values on the top, figure out what's the difference between the two, what's the change, and then same thing for the x's on the bottom. So this is the idea of rise over run, or slope. And it just tells us how it's changing consistently to be a line. So let's look at this graph before we look at the questions here. We have weight in tons along the bottom. This is our x-axis. And we have cost along the side here, which is our y-axis. So I can see that this is going up, right? Going up from left to right here. It's going up pretty sharp, actually. So pretty quickly it's going up. So as the weight moves forward, because moving to the right, the weight's going up in tons, the cost is also going up. So they're both going up. This is going to be a positive slope, or a positive change. So as we send more sugar to market, it's going to cost us more, right? The less we send, the less the cost is going to be. So it just depends. We also have a starting point here. So just like we've been doing in a lot of our other weeks here, we've been focusing on slope-intercept for quite a while. And we've been building up to it for a while before that. So this is definitely not something new to us at this point. This should be somewhat familiar, that this is our starting point. We're starting, if we do 0 tons, how many have we transported? Or I mean, how much is the cost for just the truck, it seems like, not even the sugar in the truck. So if this is our starting point, then we're starting at $500, and we're moving up a certain amount from there each time. So each ton we add, we're going to go up a certain amount. So let's look at the questions now. How much does the cost increase for each ton of sugar being transported? So for 0 tons of sugar, it's $500. We just talked about that, right? 0 tons, 500. If I go to 1 ton and I come up here to where it crosses the line, that's 2,000. So 1 ton is 2,000. We don't want to necessarily calculate it straight from here. Let's take a look at the next one really quick. 2 tons, 1, 2, 3, 4, or I don't know why I'm counting because it's by thousands. I'm being silly. So it's $3,500. We can go to, 3 tons and 4 tons. 4 tons we can actually see. So 3 tons would be the last one, and that's 5,000. So we have at least some data here. And we always want to get it right on the integers, right on the crosshairs here, because we don't want to do any guessing when we're doing this stuff. So we're going to take a look and say, okay, well, what's my change here? How much am I changing each time? Or what is it increasing every time I add a ton? So from 500 to 1,500, I had to add, 500 to 2,000, I said the answer out loud. I had to add 1,500. And then to go from 2,000 to 3,500, I had to add another $1,500. And to go from 3,500 to 5,000, I had to add another $1,500. So the change in cost every time I add a ton is $1,500. That's how much it costs per ton. So we say it's $1,500. And the slope, well, that would be the change in x over the change in y. So if my change in y, that's my rise, is 1,500, what's my run? Well, I'm going up 1 ton every time, right? Just 1 ton. So my run is 1. So if I were to reduce this, it would be 1,500. That is also my slope. That's what it's going up by every time. So that's my change on the graph here. All right. So now we're going to take a look at actually calculating slope here. And if you click on the example button, it will give you the slope formula. Because we have the slope formula down here. So I'm going to go ahead and write it on the top up here. So, and our easy way to remember it is rise over run, and that's going to equal y2 minus y1, and x2 minus x1. Well, what does that mean? y2, y1, x2, x1. What it means is we're given 2 points. This is a comma. Like this. So here are my 2 points. And the reason it says 1, 1, 2, 2 is this is point 1, and this is point 2. So it's just a notation showing that it came from point 1 or it came from point 2. That's all the little dropped number means. So we're going to have 2 points in the line. We can see that, point 1, point 2. And it wouldn't matter if I said this is point 1 and this is point 2. It really doesn't matter which one I label point 1 and 2. As long as I stick with that once I choose my labeling. We can also count this when we're given a graph. So I can actually look at this just by picturing the graph and say, well, my change in y here is 1, 2, 3, because I want to get down to the same line that the other point is on. So my rise over run, well, rise I went down 3, and then from there I'd go 1, 2, 3, 4, 5. So, and that's to the right, so that's positive. So my slope here is going to be negative 3/5. And I'm doing that visually. I'm actually subtracting the coordinates, but I'm subtracting them visually. So if I were to look at the coordinates here, and this one would be -1 and -2, and the other one is 4 and -5. Well, if I were to subtract the y values, -2 minus -5, that minus negative would be a positive, by the way, because remember in the equation here it is a negative already. So this would actually change to plus. So I'd end up with +3. -1 minus 4, that'd give me a -5 if I were to look at the x's. So I end up with 3, -5. But that's the same idea. All I did was flip point 1 and 2 when I was, when I looked at it from here to here. Well, when I stacked them, I'm actually doing them backwards. I did point 1 and point 2 backwards from what I started with. But I still end up with that same rise over run, and I still have one negative. It's still 3 and -5, or -3 and 5 are the same thing. So when we do it visually, we're doing the same thing. We're quite literally visualizing the change. All right, so let me type this guy in. -3/5. Check. All right, so we're going to visualize this guy again. So this one I'm going down 1, 2, 3, 4. 1, 2, 3, 4, 5. I miscounted there. And I'm going down 4 and right 1, 2. Well, now I have to be careful about this. If I try to check this, Alex is probably going to give me grief about it. Let's try. But it's probably going to tell me it needs to be simplified. Yeah, so it's just saying my answer is wrong. Oh, that was supposed to be 5 anyway. 1, 2, 3, 4, 5. Yeah, I'm silly. So it's supposed to be down 5 and over 2. If it was 4 and 2, though, what Alex would want me to do is reduce it. He wouldn't want me to leave it 4 and 2 because 4 can divide by 2. But it was supposed to be 5. That was just my silliness for typing in 4. So perfect. It's okay with 5 over 2 because that can't really be reduced unless we turn it into a decimal. All right, so now we don't have this visual anymore. So we need to actually use the formula here. And you can literally fill out the formula. So I'm going to show you, these are the 2 ways that I do it. And I'll do this with different colors here so we can see. So here's x2, here's y2, and here's x1 and y1. All right, so we have x2 and y2. Sorry, y2 and x2, I said it backwards. And that's over, let's see, blue. Sorry, I'm all color coding here. So we had y2, which was 8, minus -4. If you notice there's a minus negative, the original equation is minus. You have to put the minus in because it's going to react with that other negative. And then we have x2 minus -7. All right, so let's simplify this. So minus negative, that actually means a plus. So we're going to add these guys together. We're going to get 12 over 15. 8 plus 4 is 12. 8 plus 7 is 15. Well, these can reduce by 3. I can divide both of them by 3, so I'd end up with 4. 12 divided by 3 is 4, and 15 divided by 3 is 5. So here's my slope. So this is my change in y, and this is my change in x. I'm just saying, how far apart are they? So if I had +8, and I went over the line and went another 4 to the negative, well, that's a total of 12 distance. That's how far I went from one point to the other. And same thing for the x's. I started at +8, went all the way to the 0 line, and then went 7 more on the negative side. So that's 8 and then 7 more. That's 15. So I moved a total of 15 there. So it's just kind of a culmination or a combination. So if I do this, and I write these points, because I also do this sometimes, where I have them stacked. Here's point 2, here's point 1, and I'm just going to subtract them. 8 minus -7, well, it's 15. Remember, minus negative is plus. 8 minus -4, well, again, that's plus. So here's my run, and here's my rise. I just did the exact same thing. They're just stacked. I don't have to worry about making sure that x and y are matched up. So if I'm doing it in the coordinate notation there, they're definitely going to be x and then y as long as I've written them down correctly and I haven't forgotten anything. So then I'd go 12 over 15 just like I did here, and I'd reduce it. So there's just two different ways to look at it. And for whatever reason, I kind of like the coordinate where I'm stacking them, but the proper way is to do it with the equation here, definitely. This is just another way of thinking about it, where you can kind of stack them. All right, so we have 4/5. Check. Uh-oh, did we freeze? There we go. Okay, I thought it was frozen. I think my internet's just very, very slow right now. Okay, last question we're going to look at here. Uh-oh. There we go. All right, so it just took a minute to load. So I have -4, -3, and I'm going to forgo the color coding right now just to kind of make this a little nicer. So we can definitely fill this in the chart. We have x2, y2, x1, y1. So we're subtracting the y's, we're subtracting the x's. Just like I did on that last one, I just prefer, I kind of like this method. So it depends on if you don't like this method. But -4 minus 8, well, that would give me -12. I already have -4, I'm going 8 more negative, right? -3 minus negative. Now here minus negative, there's 2 of them, so that's going to be a positive. So that's the only tricky thing here is make sure you're applying that negative. If it is a negative, it's going to flip it to a positive, basically. It's going to add. So -3 plus 9 is 6. And remember, this is run, this is your x, and this is your rise, this is your y. So I have 6 over -12. Well, they can both divide by 6, can't they? So we need to reduce. So we end up with -1 over 12 divided by 2 is, or 12 divided by 6 is 2. And I put the negative in front here because this is where Alex is going to expect to see it. It's definitely, if you put it on the top or the bottom, it's not necessarily wrong, but it's going to expect to see it in that middle section there. So again, it's just a different way of looking at slope where they're kind of stacked like that, but it's doing the exact same thing as the equation is doing. It's subtracting the y's, how far apart are they? Subtracting the x's, again, how far apart are they? And then we just need to make sure we put it rise over run. This might be just going very slow here. Well, that was section 2. So I will see you in section 3. I don't think we need to wait for the check mark. Oh, okay. There, it went while I was talking. So I will definitely see you in section 3 of chapter 3 here.